Hey guys, today we are going to talk a little bit about atomic theory and isotopes. This presentation is meant to be a review, so if you have not already read the chapter, please stop watching this video, go back and review the chapter first, as this will make much more sense once you've read through the chapter. So what are we going to review today? We're going to review what does the periodic table tell us, so ways to read the periodic table. We're going to review what is an isotope, and then we're going to review isotope or nuclear symbols. So how do we symbolically represent an isotope? First, the periodic table. There are two ways to teach chemistry. The first way would be to encourage students to memorize their way through chemistry. That is not how I teach it. The way that I teach it is to use the periodic table as your cheat sheet. So for every quiz, exam, you should have a copy of the periodic table sitting right next to you as you take that exam. Throughout the semester, I'm going to teach you ways to use the periodic table as a cheat sheet. It's going to be your best friend for everything that you do in this class. If it is our cheat sheet, if it is our best friend, we should probably start to learn how to read the periodic table. So the periodic table gives us lots and lots of information in a very condensed format. First, we see chemical symbols. So chemical symbols are going to be the 1 or 2 letter abbreviation for the chemical names. I highly recommend that you guys get familiar with these symbols. As the semester progresses, you're going to just automatically need to know that He is helium and Ca is calcium and C is carbon. The more familiar you are with the chemical symbols, the better you're going to do this semester. The only way to get really good at these chemical symbols is just to practice with them, spend some time with them. So chemical symbols, the 1 or 2 letter abbreviations. This number here at the top of the periodic table is going to be the atomic number. The number may vary in its position on the top of the box, but the number will always be at the top. It may be on the top left or top right, and in this case, it's in the top center. But the number at the top is always the atomic number. The atomic number is also the number of protons in the nucleus. So atomic number and number of protons, those two things mean the exact same thing. And as you guys have discovered by going through the chapter, the number of protons is how we identify a particular element. So every atom of helium will always have 2 protons. Every atom of carbon will always have 6 protons. So that's how we define a particular element. Then lastly, the number at the bottom is going to be the atomic mass. AMU is atomic mass units. That's the unit that we typically use. The number at the bottom is the atomic mass. Now, one of the things that you're going to notice about the atomic mass is it is a pretty messy number. So it's got lots of decimal places. It's not a nice, clean, crystal number. What we're going to talk about, and this will lead us into isotopes, what we're going to talk about is how they come up with that atomic mass. Sometimes it's referred to as average atomic mass, and you'll see where they get that verbiage from a little bit later in this presentation. So isotopes. Isotopes are the next skill that we need to talk about in order to get back to that average atomic mass. So an isotope is defined as an atom that contains the same number of protons, but it varies in the number of neutrons. So here we see 3 examples of a neon isotope. So neon is always neon. It is always going to contain the same number of protons. So looking at your periodic table, we see the atomic number for neon is 10. So neon will always have 10 protons. What differs between these three isotopes is the number of neutrons. Now let's think back to what we know about subatomic particles. Neutrons, do they have a charge? No, they do not have a charge. They're neutral. But neutrons do have what? They have a mass. So if I vary the number of neutrons, that means I'm going to vary the mass of these different isotopes. And that's exactly what we see here. One isotope of neon has a mass of roughly 20 AMU. The next one is 21 AMU. The last one is 22 AMU. So we see as we add neutrons, the mass of that isotope is also going to change. Isotopes are very important to us as they're going to tell us more about how these behave, particularly when we get into nuclear chemistry. So what I want to review now is how we symbolically represent isotopes. Then we'll come back to this idea of average atomic mass. Symbolically representing isotopes. What you see here is a new way to symbolize lots of information in a very condensed picture. We as chemists, as I've said before, are very lazy. So we want to do everything in numbers and symbols. We don't want to write anything out long-wise. So what we see here is this is where our chemical symbol would go. So if we look at one of those neon isotopes, the chemical symbol for neon would go right here. So Ne. On the bottom is something that we've seen before. So on the bottom is the atomic number or the number of protons. So again, if we're dealing with neon, the chemical symbol would be Ne. And for any isotope of neon, it's always going to have an atomic number of 10. It's always going to have 10 protons. What goes here on the top is the mass number. The mass number is the number of protons plus the number of neutrons. So we're adding together the two subatomic particles that have a mass. I'm going to click back just a second here. Here we see three different isotopes for neon. I'm going to steal this guy right here. When I write neon 20, that 20 is the mass number. That's the protons plus the neutrons. So clicking forward, if I'm talking about that particular neon, the mass number would go on the top, so that would be 20. This is how we symbolically represent an isotope. There are lots and lots of questions I can ask about this symbol. I could ask you, what's the chemical? I could ask you, how many protons does it have? I could ask you, how many neutrons does it have? So take just a second, look through this information, and see if you can determine how many neutrons are in this isotope of neon. So the mass number is the number of protons plus the number of neutrons, and that equals the mass number. We have 2 out of the 3 variables in this formula, so we can very easily determine the number of neutrons. So for neon 20, the number of protons is 10, because every atom of neon will always have 10 protons. We are trying to solve for the number of neutrons. And we also know, based on this symbol of an isotope, that the mass number is 20. So doing very simple arithmetic, what we'll see is that there are 10 neutrons in this isotope of neon. And here we see the next isotope of neon symbolically represented. So take just a minute to think about how many neutrons would be in this isotope. We read this as neon 21. For this example, there would be 11 neutrons. So bringing this full circle, we've talked about isotopes. We've talked about how their masses change as we add different numbers of neutron. Now I want to bring this back and talk about how we get that average atomic mass. Remember that number that we see at the bottom of the periodic table. So here are the 3 different isotopes of neon. To get the average atomic mass, you're probably starting to think, okay, there's 3 isotopes of neon that exist. Maybe I'll take an average of those 3 isotopes, and that'll give me that average atomic mass at the bottom of the table. You're close. As it turns out, all 3 of these isotopes for neon exist. The problem is they don't exist in equal amounts. So it's not that we have 33.3% of neon 20 and 33.3% of neon 21 and 33.3% of neon 22. They exist in different amounts. The amount that they exist in is called the natural abundance. So this is not something that you're going to be tested on or need to know. I just think that it's really good information so you can understand that number at the bottom of the periodic table. So the natural abundance is how much neon 20, for example, we would find in a sample of neon. So let's say in my office, I've got a jar of neon gas sitting on my desk. I reach into that jar, I pull out 1 atom of neon. 90% of the time, I will pull out a neon 20 isotope, 10 protons, 10 neutrons. Going down to the bottom here, 9% of the time, I'll reach in and I'll pull out neon 22. So 12 neutrons and 10 protons. And 0.26% of the time, so almost never, 0.26% of the time I'll reach in and I'll pull out a neon 21. So those are the natural abundances. That's how much of each occur in nature. So to get that average atomic mass that you see at the bottom of the periodic table, we take a weighted average. So to do that, we would take the mass times the natural abundance, mass times natural abundance, mass times natural abundance, and then we would add those numbers together. Again, not a skill that you're going to be tested on, but it helps us understand what atomic mass is and why it's such a messy number. So before I leave you guys, I want to just quickly review this idea of writing an isotope symbol. So go ahead and pause the video, take some time to work through these, and then I will pick up and work through them with you. So write this isotope or nuclear symbol for A, B, and C. Okay, for letter A, the chemical symbol for letter A is going to be carbon. Well, how in the world did I know that that was carbon? I didn't tell you it was carbon. There's nothing on the screen that says it's carbon. I looked to the number of protons. Remember, the number of protons defines what element we're dealing with. So looking at the periodic table, I see that carbon has an atomic number of 6. That's how I knew that it was carbon. On the bottom is where we put the number of protons, or the atomic number. So that's going to go down here. And on the top is going to be the mass number. So remember, the mass number is protons plus neutrons. So 6 protons plus 6 neutrons is going to give me a mass number of 12. So that goes up here. So this would be the answer that you report. What is the isotope symbol or nuclear symbol for an element that has 6 protons, 6 neutrons? It's right there on your screen. So the next one, 11 protons, 12 neutrons. Well, now you know how to find the chemical symbol. I go to the periodic table. I find the element that has 11 protons, and that would be sodium. Atomic number goes at the bottom. Mass number goes at the top. So 11 plus 12 is 23. And lastly, 92 protons. So we go to the periodic table. We find the 92nd element, and that is uranium. Uranium has 92 protons, so that number goes at the bottom. And I take 92 plus 143, so it has a mass number of 235. I picked this particular example. Uranium-235 has lots and lots of uses when we get to nuclear chemistry. So we will certainly see these nuclear symbols or isotope symbols come up again in chapter 5. And uranium-235 is one of the heavy hitters for nuclear chemistry. So I picked that example just to give you something to use. I hope you find this helpful. Again, email me, reach out to me if you have any questions or comments. I hope you guys are all doing well.